my YouTube channel. So let's continue with the molecular orbital theory, MOT part 5. So in this part 5, we are going to discuss about the bonding in the p block element. Alright, so for the bonding in the p block elements, okay, the higher the bond order, you're gonna have a greater bond energy, and also the shorter the bond length. Okay, other than that, other than HOMO in previous part 4, okay, we have discussed about HOMO and also LUMO, right? Okay, so we have two kinds of magnetism, which first one is what we call paramagnetic, and also for the second one is diamagnetic. So what do you know about paramagnetic? So, in order to determine the paramagnetic compound, you will see unpaired electron. Okay, where this kind of paramagnetic compound or paramagnetic molecules, usually they attracted to the magnetic field. And if we have this diamagnetic compound, usually they have a paired electron, and also they unaffected by the magnetic field. So, let me show you how to determine the paramagnetic and also diamagnetic compounds or molecules. Alright, so in this slide, okay, here we have the sp mixing and also without sp mixing. Okay, so if you look at, okay, let's focus here. Let's focus to the with sp mixing. If you look at the boron 2 here, we have a 2 unpaired electron. Okay, in this boron 2, then it can be considered as paramagnetic. While for the carbon and also nitrogen, all of the electrons are paired. Okay, so what happened here, carbon and nitrogen here can be considered as diamagnetic. Okay, minimum, okay, in order to become a paramagnetic, you need to have 1 unpaired electron. So it same goes to the oxygen here. Okay, we have a 2 unpaired electron, so this oxygen is actually a paramagnetic. Okay, while for the fluorine and neon, both of these are diamagnetic. Okay, because all of these are paired, or they have a paired electron. Okay, so right, so other than this, you can determine the bond order. Okay, from these all 6 compounds or 6 molecules, neon 2 does not exist. Okay, and you can draw the valence electron configuration. Sorry, you can write down the valence electron configuration from this molecular orbital. Start from the bottom to the top. Okay, alright. Okay, other than that, you can see the bond length. What happened? Okay, here, if we have a higher bond order, you're gonna have lower ataupun shorter bond length. Okay, in this case, the highest energy here is for the nitrogen N2, 945 kilojoule per mole, because the bond order here is 3. Okay, alright, and then other than that, okay, we can determine the bond length and also the bond energy. Okay, alright, so the difference between these two is the arrangement of this level, the pi to p and sigma to p for the with sp mixing, and sigma, and also followed by pi without sp mixing. So these are examples, okay, for using MO theory to explain the bond properties. Okay, we can determine the bond order. Alright, here, so because the nitrogen is having the bond order of 3, so it has a bond energy of 945 compared to the N2 plus. Okay, where the bond orders here, the bond order here is 2.5, and the bond energy is 8.841 kilojoule per mole. Okay, other than that, we have oxygen and oxygen 2 plus. Okay, where for the plus here, we are going to have less 1 electron. Okay, if we have negative here, we're gonna have extra 1 electron. It depends, okay, on the charge here. Alright, so from the bond orders here, okay, this is 2, while for this one is 2.5. So it means that O2 plus has higher bond energy compared to the O2, okay, with the value of 623 kilojoule per mole, and while for this one O2 is 498 kilojoule per mole. Okay, so this is the difference, okay, between mixing and also without SP mixing. Okay, so from this one, okay, alright, we can determine, okay, this is just a summary of the properties of homonuclear diatomic molecules, okay, and from this molecular orbital you can determine the HOMO and also LUMO. Okay, for example, let's say we have lithium 2, the HOMO, highest occupied molecular orbital here, is the sigma 2s, while for the LUMO, the lowest unoccupied, where we have a no electron at all, is the sigma star 2s. Okay, while for another example, let's say I have an N2, the HOMO will be here, is the sigma 2p, while for the LUMO, this is HOMO, LUMO is here, is the pi star. Okay, alright, so you need to differentiate, okay, between the HOMO and also LUMO. Alright, so okay, let's look at the oxygen here. Okay, from the molecular orbital, okay, you determine, okay, that we determine that the oxygen is a paramagnetic molecule. Okay, but what happen if you draw the Lewis diagram? Okay, if you draw the Lewis diagram, you will get this kind of diagram where it indicates that oxygen is diamagnetic. Okay, but alright, the MOs, okay, shows 2 electron unpacked. Okay, here, back to here, we have a 2 unpacked electron, and okay, from the experiment, okay, alright, it shows, okay, that the oxygen is paramagnetic because this liquid oxygen is attracted to the magnet. Okay, and actually the correct one for the Lewis diagram for oxygen is like this, with 1 bond here. Okay, so alright, so this is where the MO can double confirm, okay, the magnetism of the oxygen or magnetism of other molecules. Okay, alright, so that's all for part 5. I'll see you guys in part 6. So don't forget to like, comment and also subscribe to my YouTube channel. So I'll see you guys in next part. Bye.